So I went through an entire video up at the board going over how to do these problems, which is where I got all of the notes for. And for some reason, the recording was not set correctly. So I hope that this one does things the right way. Otherwise, I would have just gone through this twice. So I'm sorry that I'm not doing these in live time, but I do want to go through and explain a couple of things. This is example 3. And this is looking at a quadratic and an x squared minus 9. It wants to know where it's positive and where it's negative. So the first thing is to make this graph, I actually made this table of values here. I started by picking 0, and then I did 0 squared minus 9, got back negative 9, and plotted this point down here at the bottom. Then I just picked 1 and negative 1, and I went out a little bit further and went 3 and negative 3. Typically, if you pick values between negative 5 and 5, those are going to be enough to get you an accurate picture. This is called a parabola. It is a U shape. When you connect it, make sure that you don't have any sharp edges with it. It should be kind of rounded at the bottom. So then we have the positive, and we have intervals where it's negative. Now, when we name the intervals, we're actually looking at the x values. And so for positive, those are these pieces I circled here in yellow. So both of these yellow circled halves or pieces here that are sticking out on the edges, those are both above the x-axis, which means those are the areas where your graph is positive. So we want to name the x values that match up with that. And if you follow that down to the x-axis, it looks like the graph is going to start being positive at negative 3, and it's going to be positive for every x value below negative 3. Because in interval notation, we always start with the lowest value, that's where I get this negative infinity to negative 3. And I have a parenthesis on the negative 3 because technically at negative 3, it's not positive or negative, it's neutral because it's at 0. This right-hand piece over here at 3, it's going to start being positive, and then it's going to be positive for every x value that's greater than 3. So that's where the 3 to infinity comes in. So there's 2 regions where this graph is positive, and that happens a lot with quadratics if they are opening up. If they're opening down, then that's a slightly different situation. Now negative is going to be this light blue circled area here in the middle. That's where your graph is below the x-axis, and that's going to be all the x values in between negative 3 and 3, because all the y's that match up to things that we plotted between negative 3 and 3 were below the x-axis. And you can see that in the table. 0 and 1 and negative 1, those all gave me negative negative y values. So when we say positive and negative, we're saying where are the y values positive, where are the y values negative, but the x actually gives you the location for that. The next example was looking at increasing and decreasing. And again, I have this function, g. This is an absolute value function. Absolute value functions are opening up or opening down with this V shape. So again, I made a table. I just started picking some values. I did want to make sure that I got enough values, so I did see that nice V shape here. And you can see I have my 5 dots, and when I connect them, I can extend those, and I have a consistent slope on each side. For increasing, and notice again, this does say which x values. So again, I'm identifying x values where this is happening. To be increasing, it has to have a positive slope. It has to be going up. And if I look here on the left-hand side of my graph, as I look from left to right, my graph is going upward. So this side has a positive slope the entire way until this point here. Well, this point has an x value of 0. So that is where my graph is going to stop increasing. It's going to be increasing from negative infinity to 0. For decreasing, once I leave this value of 0 and start moving further to the right, my graph is going down, which means it is going to be decreasing. So this one is decreasing from 0 to infinity. With quadratics and absolute values, you are always going to have half the graph that is increasing and half the graph that is decreasing. Linear functions are different because with a linear function, the entire graph is increasing or the entire graph is decreasing because of the nature of the consistent slope. Slope does not change in an individual line, so that's why we would say the whole thing is increasing or the whole thing is decreasing. The last thing we're going to look at is average rate of change, which is just a fancy way of saying slope. And I'm really sad that this one did not come out because this is basically how we derive the slope formula, but with functions instead of just y2 and y1. So this interval here from a to b, those are both x values. And they don't actually tell us the y values, but they do give us this function here that says y is equal to f of x. So to find the y values for each of these x's, we would plug this in. So if my x1 is a, I would plug the a into the function, which means my y1 is f of a. If my b is x2, to find my y2, I would take the b and plug it in, and I would get f of b. So that would be my y2. So our two ordered pairs are over here. I have a, f of a, and b, f of b. Then my average rate of change, which is your m, would just be the same thing as we've always had. My y2 minus y1 over x2 minus x1. The only difference is you have these functions here on top. They don't actually tell you what the ordered pairs are. This next example is worked out completely in the PDF that is attached of the notes. I actually worked through this middle one together here so you could see how this works. So in this first box here, we're given not ordered pair, but the interval, -2 to 0. So -2 would be our x1, 0 would be our x2. To find those function values, we would actually plug them into this g function because this middle box here and this middle column is what we're going to solve. So if we plug in -2, I replace this x with a -2. 1/2 times -2 minus 1 gives me -2. If I plug in 0, 1/2 of 0 minus 1, half of 0 is 0, minus 1 is -1. And then I do my y2 minus y1 over x2 minus x1, like we do whenever we're finding slope, and you end up with 1/2, which is not surprising for this middle box because this is a linear function, and linear function, it says 1/2 x in the question, which means it's going to have a slope of 1/2. So again, these other problems, the other boxes are worked out on the PDF. You can take a look at those if you want to get some more explanation. The last thing I have is just something I want to point out, and I won't spend as much time on this in the future explaining where it is and what it is, but there's a concept summary. In every textbook, in every section of our textbook, at the end of the section, there's always something that summarizes all the important concepts and formulas and even vocabulary that was introduced in the section. So for 1-1, this is page 10. If you open up to page 10, it'll actually go through increasing, decreasing, positive, negative, rate of change formula. So all of those important things that you would need to take away from 1-1. And then as you can see down here, you have an assignment in Savas 1-1 Math Excel. You can go through and work on that, and that's going to count as your homework. Remember, that's due Friday night by midnight, so make sure you get that finished. And let me know if you have any questions on what we've covered.